Now we're going to look at the position of hydrogen in the reactivity series of metals. Now the same concept of how carbon can remove oxygen from metals. So now we are talking about hydrogen. How hydrogen can remove oxygen from metals. Okay, so by looking at this reactivity series of metals, we know that hydrogen, okay, is between zinc and iron. Alright, so that means to say hydrogen is more reactive than iron. So hydrogen can remove oxygen from iron. Hydrogen can remove oxygen from tin. Hydrogen can remove oxygen from lead. But hydrogen cannot remove oxygen from zinc. Hydrogen cannot remove oxygen from aluminium because hydrogen is less reactive than zinc, less reactive than aluminium. Okay, so this is the experiment that we use to find out the position of hydrogen in the reactivity series of metals. So you can see that over here you have zinc and dilute sulfuric acid, okay, and copper 2 sulfate solution. Copper 2 sulfate solution is a catalyst. It makes the reaction become faster. Acid and zinc will produce hydrogen gas. So hydrogen gas will flow into this U tube where there is anhydrous calcium chloride. Anhydrous calcium chloride dries the hydrogen gas. So dry hydrogen gas enters into this combustion tube. Okay, there's metal oxide on a porcelain plate in the combustion tube, and we heat up the metal oxide. So dry hydrogen gas will react with metal oxide in the combustion tube. So this is an experiment. Okay, this is the experiment that we are looking at now. Inside here, hydrogen gas react with the metal oxide. So hydrogen and aluminium oxide. Hydrogen and aluminium oxide. Okay, let's take a look. Hydrogen is less reactive than aluminium. So there is no reaction because hydrogen cannot remove the oxygen from aluminium. So there's no reaction. Aluminium oxide does not glow. Nothing happens. So we say hydrogen does not reduce aluminium oxide. Okay, reduce here means remove the oxygen. Okay, hydrogen and zinc oxide. Okay, let's take a look. Hydrogen and zinc oxide. Can hydrogen remove oxygen from zinc? Cannot, because hydrogen is less reactive than zinc. Hydrogen less reactive than zinc, so nothing happens also. Okay, so zinc oxide does not glow. Alright, but when it's hot, the zinc oxide is yellow in color. When it's cold, then zinc oxide is white in color. So that you see is actually the color of zinc oxide. That observation is the color of zinc oxide. Nothing to do with the reaction between hydrogen and zinc oxide. Okay, because hydrogen and zinc oxide does not react. So hydrogen does not reduce zinc oxide. Now hydrogen and iron 3 oxide. Okay, let's take a look. Hydrogen is more reactive than iron. So hydrogen can remove oxygen from iron. So hydrogen can reduce iron 3 oxide to become iron. So there's a reaction. You can see it burns brightly, and the reddish brown powder is actually this iron that is produced. Okay. Next, hydrogen and lead 2 oxide. Hydrogen and lead. Oh, hydrogen is more reactive than lead, right? So hydrogen can remove the oxygen from lead. Hydrogen can reduce lead to become reduce lead 2 oxide to become lead. So you can see that lead 2 oxide burns brightly. There is a reaction. Okay, and the yellow powder, which is lead 2 oxide, changes to become shiny grey. The shiny grey is this lead lah. Okay, that's the product. So you will see at the end of the reaction, there is a shiny grey product, which is lead. Okay, how about hydrogen and copper 2 oxide? So you see, hydrogen is more reactive than copper. So there is a reaction. Hydrogen can remove oxygen from copper 2 oxide. Hydrogen can reduce copper 2 oxide to become copper. So you will see in the reaction, copper 2 oxide burns very brightly. There is a reaction. Okay, because hydrogen can remove the oxygen from copper 2 oxide. Hydrogen can reduce copper 2 oxide to copper. And this black powder, copper 2 oxide is black in color. This black powder changes to become brown because the black powder, which is copper 2 oxide, becomes copper. And this copper is the brown powder. Okay, I leave you to answer these questions on your own. You underline the correct answer. Okay, and that's all for today's lesson.